Hey, what is going on? So, I decided to finally get it printed, and here it is. It took just a little over an hour, and right there is where you put the Velcro strap through for the magnetic hanger. And these obviously snap in place of the probes, and this part goes in place of where that little slot is right here. So before we try it on, see if I passed or failed, this is what gave me the idea. Actually, okay, so this is the first idea I had. As you see, there's two holes here, and then right here is where the Velcro would go through, and then I was going to have like the probe shaft things that go into here be tapered at the top, so then they, can't fall through the hole. But the problem is I have to have the shafts bigger at the bottom also, to where they don't slide up out of it and then have the meter fall. And if the shaft is bigger at both ends than it is in the middle, there's no way to slide it into the hole if it's bigger than the hole. So what I had to do was design it in a couple of pieces. So you would put the shafts into here and then put them together like that, and then these slots in the middle line up. And then this piece, obviously because there's a bridge here, I couldn't print it up and down wise. I had to print it sideways. Some people have been successful at bridging. It's where you set a higher print speed and then your printer will bridge across, and then it'll actually print just like this with it upwards, I guess would be the right terminology. But I didn't want to risk it, so I just printed it downward like that. So then you would just push it through the hole, and then there you go. Now the little holes on the side are locked. It works, and it's kind of one of those little clever solutions you have to come up with when you do 3D printing, because you can't print in midair, because obviously you have to have something to print onto. So you can't have overhangs and such unless they're really short distances and you're printing at a really high speed. But the problem is, the higher the speed you print, the more unreliable your print will become. So I didn't actually finish this. This print failed partway through, and actually I had maybe 10 failed prints in a row, not kidding. So the printer, despite being fixed, is still a piece of shit. I think a heated printer bed that's actually level would help. And that might be all it takes to get this thing printing a little more reliably. But it's stupid that it's not reliable in the way it comes out of the factory. And this is with the upgraded extruder, the one with the little spring-loaded lever that has a ball bearing on the other end, which replaces the really shitty spring-loaded plunger, which is just a piece of plastic that pushes the filament against the driver gear. I mean, who came up with that? That is retarded. And what pisses me off is the MakerBot stole that design from a guy that made it and put it up on Thingiverse, and thousands of people downloaded it and upgraded their own printer because the stock design sucks. MakerBot bought Thingiverse, and I believe through some loophole in their terms and conditions, they were able to legally take that design, use it on their commercial model, and from the last I knew, the guy never got a penny out of it. So fuck MakerBot. But I think I've already made that point clear that I don't like MakerBot. So anyways, yeah, lots of failed prints last night. It was either I would get the print to stick to the build surface, but then the edges would curl up due to not having a heated build platform, or it would appear to stick, and then maybe 3 or 4 layers into it, it would pop off the surface and start sliding around, which obviously is not ideal, and then it creates a bird's nest, and it's shitty. And I tried over and over, and I realized that part of the problem could be I was printing multiple parts, and it's really hard to get an uneven acrylic build plate leveled. I use the utility built into the device to do the leveling, but you can't get it perfectly level. I level each corner and you adjust one and it puts the other one out of whack, and it's just because the piece of acrylic they give you is not completely flat. Some people got flat ones, tons of people got curved ones like mine. They should have used glass or something more flat, and they should have included a heated build plate for free, because from what I'm seeing, that's the only way you're going to be able to get this thing to print reliably every single time without having to worry about wasting a ton of filament. I mean, I do not feel confident in this printer enough to start like a 5-hour print and leave the house, because I'm going to come back to a rat's nest. And I have before. You saw the box from my last video full of filled prints. Now it's just like a tenth of them, a fraction of what I've actually wasted. So enough rambling on. I decided to print one piece at a time this morning. I was like, a good night's rest, I got a fresh mind, how about I redesign it? Well, change the design a hair, but I was going to print one piece at a time. That way the print head isn't having to go to different parts of the build platform that might not be at the right level because it's warped. So I just print right in the middle and get the middle calibrated perfectly. And so I was going to print one piece at a time, which, you know, it's a good plan, right? It'd take longer, but at least I would actually be able to get the prints working. Just like, you know, the test print works, but it's in the center of the damn thing and they're tiny little prints. But, you know, you go to print your own thing, and that's where the trouble happens. So while I was doing that, this is the plastic piece that came with the hanging kit, but it's not for this model. If this is for the other models. I don't remember exactly which model number, but it's not wide enough. But what it does is it snaps into there. But as you can see over here, it's not wide enough. The model this fits is a lot skinnier. So when I looked at this, I thought, hey, if the Velcro strap could go around there, this is a one-piece solution. And from looking at it, besides this overhang right at the top, there's no overhangs. I could print this up and down like this in one shot, one single piece. And instead of doing an overhang, I decided that I would do the slot at the bottom, so the slot goes through up and down wise. That way there's no overhangs like this model has. And this is what I came up with. So I have not tried it on yet. All I've done is just popped it off the build plate and fired up this video and audio recording. So moment of truth. Hopefully I don't look stupid and fail. But hey, failing is a part of making. Ooh, it's a tight fit. Well, it's promising so far. Damn it, I don't think it's gonna fit. Yeah, this doesn't go down all the way, and this is almost flush with this edge. So, oops, I need to make that skinnier. But the shaft diameters are perfect. So, and you know, now that I look at this, I have tons of room down here. This is sticking out enough that I have a feeling that when I hang it, it's going to lean at an angle like this. So I might redesign it to have this inwards more. And actually, I might make the ends hollow, because A, that'll save filament and it'll save print time, but B, I can print another piece, like a male end, that would slide into there that goes across, and I can even put the slot on that piece as well. So that way it's even closer to the top and closer to the unit itself, so then it won't lean as much. And it'll make it stronger because it'll be reinforced from the top and the bottom. And you'd still be able to pull it on and off. Well, I would have to make these just a hair longer to support that ability. So I'll probably lengthen these, make the ends hollow. Probably won't print that piece immediately, but I'll at least add support for it. And then I'll have to make these skinnier to be able to get them to fit. Yeah, it's like a little half circle down in there. And this is just way too big. So, let's see. Yeah, I mean, it's not a huge difference, but you can definitely tell that this one's bigger around. So I'm just going to trim this down around the edge, take a little off the diameter, and then move this inward so it'll come out and then down. That way the Velcro connects closer to the unit, so that way it'll hang more evenly. Make the ends hollow, and I think that's all I'll do. That should do the trick, I think. And then it'll snap right in. Even though this part didn't push in all the way, it probably was strong enough that I could have just used it this way, but I got that perfectionist bug, and it just bugged me too much to call it good there. So I'm going to go ahead and redesign it, and you know what? I will fire up screen capture, and I will actually just record myself fixing it, so anyone may be interested in seeing how the 3D design for this stuff goes can see how it's done. Or, well, I suck, so in my case you can see how to do it incorrectly. So yeah, let's head to my main rig, and we will redesign the file to reflect the changes that I just mentioned, and then we'll reprint it, and then we'll see if we can get one that fits. Hey, what's going on? I have just now finished the second print. So there's the first one, and what I believe to be the problem, I didn't fit quite right. It fit pretty close, but not quite right. I think this was too big around. And so what I did was made it not quite so big around, and then I changed the design a little bit. So with this one, the multimeter goes on this side, and the point where the Velcro connects to this for the hanger is so far out that it makes the multimeter tilt forward whenever you hang it from something. So on the new prototype, I moved that forward a bit. It's kind of hard to tell without fitting it how close I can get. I can take some rough estimates, but everything on the back of that meter is angled, so it makes it really hard to mock it up in CAD. So anyways, let's pull it off and then see if it fits. This build took 59 minutes, so it was actually quicker than the other one. But oh, another thing I didn't do in the other one. The other one, the ends, this it's 100% infill, and this is too. But the ends are filled. These are filled all the way through. On this one, I have, I think, like 10 millimeters worth hollow on the end. So that way I can build another piece that has a part that goes into there that bridges across at the top of the multimeter to give it more strength if I decide that I need it. If I don't, then I'll just use it as is. But hey, it can never be too strong, right? And my method of attaching it would have just been super glue. There we go. So there's the bottom. Looks okay. Does not look too bad. Feels a little more rigid than the other one, actually. So there's the holes in the end. So, moment of truth. Look at that. Look at that. That is a thing of beauty right there. I love it. And then I made the top stick out just a hair more, just to be sure that it was far enough up that I can make a little connecting piece to make this stronger. Or another option was to make a connecting piece that has another slot in it up here, so that way I could have it hang even farther away from this point. So that's if you wanted a longer hanging strap. I prefer shorter, so I don't even think I'll need to do that, but this is, I mean, that's on there. You would have to try pretty hard to break that, so freaking awesome. So yeah, in the description of this video I'll put up the files for this. I don't think I'll make any modifications. I might go ahead and make a piece that goes across there for anyone who wants to print it, just to make this even stronger, because it sticks up far enough here that even with a piece attached across there, you would still be able to pull this on and off, because you basically are forcing it straight down into these the probe holders. So yeah, let's put the strap on it. So it will go this way, and there we go. There we go. Sorry, the mag light, my mag lamp light was just a little too bright. Probably should have put this on beforehand, but whatever, it's working. I want it shorter, so we'll pull more through there. And then through the top part here. If I can get it. There we go. Look at that. It's still a little longer than I'd prefer. Maybe I'll have to make some kind of a clip to put there so it shortens it. Because that is quite a bit longer than the minimum length that I can get my Fluke one. It's not that big of a deal, but for what I'm going to do with it, it would be much better if it were like this. So I need to find some way to clamp that so then it'll be shorter like this. But there you have it. I guess one of the real life practical advantages of having a 3D printer. You can get out your calipers, take some measurements, and without really having any sort of skill in 3D design at all, as you can see I don't, everything is very square and boring. I mean, I did attempt to do a little bit of curved edges here and there to make it not look so crappy, I guess, but I think it turned out pretty great. I kind of wish I would have got out some gunmetal colored filament to match this, or even some orange, but oh well, black works. Matches the strap. So now I'm kind of wishing that I would have, maybe I could print a second one and load test this and see how many pounds of force it would take to break this, because this, I mean, I'm pulling that really hard and it's not moving. So yeah, that's in there pretty good. Cool. That is a success. Haven't had a lot of successful projects in recent times, so I'm kind of glad that worked out. And I guess it was good that I got the 3D printer out, because definitely have not used this thing for a long ass time. So I was thinking I might have even had to do a third video, but luckily my second attempt worked like a charm. But like I said, I will put the files up, probably not Thingiverse. I hate that MakerBot bought them. And then, you know, there are not a lot of competitors. There's Shapeways, but Shapeways is a pay site. You know, there's higher quality files potentially, but you got to pay for it. And it's a crappy deal. So instead of Thingiverse, unless, well, if I can't find anything else, I'll put on Thingiverse, but I'm going to try to find some other alternate hosting location, and I'll put the file up there. But I don't imagine there are a lot of people that have the U1253B Agilent or Keysight multimeter, because out of all their Agilent multimeters, it's probably the one with the biggest fatal flaw being the really crappy battery life, and you basically can't use it outside unless it's cloudy out, because despite the screen being super sharp with a really awesome contrast indoors, outdoors it washes out and you can't see crap. So I'll put the files out there anyways, is basically what I'm getting at, but I really doubt anyone out there will actually need it or want to hang this unit, because people wanting to hang this will probably be people who actually use it out in the field. People out in the field will not buy a multimeter that you can't see in daylight, so yeah. But I'll put it out there anyways. And is that it? Yeah, I guess that's it. If I print the little piece for the end cap to make it even more strong, I'll probably do another video just to show that off and say, hey, look, I went ahead and did that, and here's how it fits, and here's how it works. But other than that, I guess that'll be it for 3D printing, at least for this week. So I will see you for the next video.